Okay, so variables on both sides of the equation. We're going to start off simple, okay, with just a simple process where you have them in the ax plus b on one side, ax plus b on the other side. So we're just going to be focusing on the movement with how you move variables from one side to the next. Okay, so when we are moving variables from opposite sides of an equal sign, you need to add or subtract the term to both sides. Okay, when we are moving a constant, we add or subtract it to move it to the other side. Okay, not to simplify it, but to actually physically move it to the other side. It's the same thing if you are moving an entire term. So I know usually you'd see 3x and you'd go, oh, well, that's a coefficient I need to divide by 3. But this time, I want to move the entire term over to one side. It doesn't matter which term that you're moving. I typically suggest moving from right to left. Okay, taking whatever's on the right side and moving it to the left side so that you always have it as in this variable equals, x equals or y equals. Okay, so focusing on just the whatever variable happens to be on the right side, we're going to move it over to the left side. Okay, so we always still follow the same process. We always look to see, can we distribute? We always look to see, can I simplify the left side? Can I simplify the right side? But once you have done all of that, where it's simplifying or shortening your equation down, then you start doing the movement, the solving portion. You look to see, do I have variables on both sides? That's your technical third step. Okay, so here we have a variable on both sides of the equal sign, so I want to focus on moving the smaller of the two variables over to the other side. So I'm going to go ahead and write this equation up here real quickly and show you exactly how we would go about solving it, because I don't have much room right here. So for me to move the 3x over to the other side, the first thing I'm going to note is that 3x is a positive value. Therefore, in order to get rid of it, I'm going to subtract it from both sides. Now, when I subtract it to the other side, am I going to subtract it from negative 6x or from positive 12? Negative 6x, right? I want to subtract it from a like term. So I'm going to subtract it from that negative 6x. And now these 3x's on the right side are gone. A negative 6x minus the 3x becomes a negative 9x. We still have a plus 12. And the whole thing is now set equal to negative 15. And then we could go about solving like we normally would do. We would subtract 12, then divide by negative 9. Okay, it's just the process of going ahead and moving one variable to the other side. If you're moving a variable, if you're moving an entire variable to another side, you use addition or subtraction to do so. So let's take a look at problem number 1. Again, this is a simple problem. Yes, you probably could do this eventually in your head, like what we just did here. I just realized that I have it written here. All right. Bruh, my bad. Yeah, well, now you get to write it again. Isn't that fun? All right, so we have negative 9x plus 12 is equal to that negative 15. We would go ahead and get rid of the 12. Move the 12 to the other side by subtraction. So we're subtracting the 12 from both sides. That's going to leave you with a negative 9x is now equal to negative 27. And then our last step is to divide both sides by negative 9. And I'm trying to get you guys used to the idea that division is just a fraction bar. Because when you guys are getting into your delta maths, sometimes your answer is just going to stay a fraction. So if you set it up as a fraction to begin with, set your division problem up as a fraction to begin with, it makes it a lot easier when you're simplifying. Okay, so x is going to wind up equaling a positive 3. So once again, start with the variable that's on the right side. Move it to the other side by either adding or subtracting the variable term. And then you're just down to a two-step equation. Get rid of the constant, get rid of the coefficient. So if we're taking a look at problem number 2, we have 8x plus 7 is equal to 5x plus 19. I have no distributive property. Both sides are as simplified as they're going to get. So now we're going to focus on moving the 5x to the other side. How are we going to move the 5x to the other side? Sebastian? Good. So we're going to subtract 5x from both sides. We're going to subtract the 5x away from the 3x as well. So 8x minus 5x is going to give us 3x. Plus 7 is going to come down. And it's equal to a positive 19. That comes straight down as well. I don't have to write the positive sign for that. Okay, what's my next step? Nathaniel? Subtract the 7. So we're going to subtract 7 from both sides. The 7s are then going to get crossed off. We now have 3x, and it's equal to 12. Our remaining step, Ava? Divide by 3. So when we divide by 3, we're going to get that x is equal to 4. Okay, so we know that they're not always going to be nice and simple like that. Sometimes you are going to have something more complex, like problem 3. Like I said, you would not want to try to compute problem 3 in your head. You would not want to do that without writing some steps down. So taking a look at problem number 3, what is the first thing that I need to do? Maritza? Distribute. Okay, so we are going to have distributive property. We are distributing a positive half to this 8x and to this negative 1. We have an 8x and we have a negative 1 that we are distributing it to. So I'm going to do a half times 8x and a half times negative 1. When we multiply a half times 8x, that becomes a 4x. When we multiply a half times negative 1, that becomes a negative half. Okay, everything else on this side is still going to come straight down, so we still have a negative 3x. Now, what do I need to put in between the negative 3x and the 4x then? A plus sign. Because that 4x was a positive, we're going to put a plus sign in between them. I can bring down my equal sign. I can bring down this negative half. But then I'm going to stop because I see distributive property again. I see a plus 6 that needs to be distributed, or a positive 6 that needs to be distributed to 4/3 x and to negative half. So that means I'm going to be doing 6 times 4/3 x. And I'm going to do 6 times negative 1. So 6 times 4/3 x is going to come out to a positive 8x. So I'm going to write a positive 8x. Then 6 times negative 1 becomes a negative 6. Okay, I've distributed. What do I need to do now? What's the next thing I need to do? Jeremy? Combine like terms. Okay, so let's take a look at this side. Are there any like terms that we could go ahead and combine together? Yeah, negative 3x and a positive 4x, right? I can go ahead and combine this material right here together. This information can get combined together. So if we were to combine that, that's going to become a positive 1x. Do I have to write the 1?
No.
No, I don't have to write the 1. So I could just write an x. Okay, we still have this minus half, and it's equal to, what about on this side? Can I combine any like terms on this side? Yeah, what can I combine? Negative half and negative 6, right? Negative half and negative 6 can go ahead and get combined together. So if I were to do a negative half and a negative 6, then that's just going to become negative 6.5. We still have this plus 8x that's going to come straight down. All right, we have it down as simplified as it's going to get. Now we have to start solving. What should I do first? Sebastian? Good. We're going to subtract 8x from both sides. Now remember that x technically had a 1 in front of it. So if you want to write the 1, you can. So we're doing 1x minus 8x. That's going to give us a negative 7x. So we have a negative 7x minus a half is now equal to negative 6 and a half. Next step. Come on, guys. It's a two-step equation. What are we going to do now? Daniel. Well, it's already subtraction. So we should do add by 1/2. We should add a half to both sides. We're going to add a half to both sides. That gives us negative 7x is now equal to negative 6. What's our last step? Nathan, what's our last step going to be? Dividing by negative 7. So we're going to divide both sides by negative 7. Now when we divide by negative 7, negative 6 and divide by negative 7, that's not going to come out to anything pretty, so we're going to leave it as a fraction. X is going to be equal to a positive 6 over 7. That is not something you want to try to do in your head, guys. You want to write your work down. You want to organize your thoughts. It makes it a lot simpler. You want to make sure that you are able to keep it all organized. Okay, we'll do one more together. We've got negative 5 plus 7x minus 3 is equal to 2 times the quantity of x plus 1. Eli, what are we going to do first? Distribute. Okay, so we're going to do 2 times the quantity of x and times the quantity of 1. So if we do 2 times the x and 2 times the 1, that becomes a 2x and a positive 2. So now on the other side, we still have negative 5 plus 7x minus 3. Next step. Angeline, what do we do now? Combine like terms. What can we combine? But they're on the different sides. You can't combine them when they're on different sides. You have to simplify only the same sides. So if I'm just taking a look at this side, are there any terms that I can combine together? Negative 5 and negative 3. Okay, so we're going to go ahead and combine negative 5 and negative 3 together. So negative 5 minus the 3 is going to come out to a negative 8. Okay, 7x doesn't have anything that it can be combined with, so we're just going to bring it right down. So plus 7x equals, can I simplify anything on the right side? No. 2x plus 2 is as simplified as it gets. So 2x plus 2. Okay, now we have it to where it's variables on both sides. Hayden, what are we going to do? Move the variables first. So what are we going to do, Hayden? Okay, so when we're looking at here and we're wanting to move a variable to both sides, we only use addition and subtraction to move the entire term. So we're trying to move the entire term, the entire variable to the other side. So what are we going to do to it? Are we going to add 2x to get rid of 2x? No. 2x plus 2x would give you 4x. Huh? Okay, so again, one more time up here, honey. When we are moving a variable term, I'm not trying to keep the variable alone. I don't want to leave the variable there. We only divide or multiply to leave a variable where it's at. But this time I want to move this variable to the opposite side. So if I'm moving things to opposite sides, I use addition and subtraction. When I want to keep the variable stationed, then I use multiplication and division to simplify it. Okay? But we are moving the entire term. So we are going to subtract 2x from both sides. We're going to subtract 2x away from the 7x as well. So we have negative 8 plus 5x is now equal to a positive 2. Chase, what do we do next? Add 8. Good. We're going to add 8 to both sides. That's going to leave us with a positive 5x is equal to 10. Mason, next step. Divide by 5. So we're going to divide both sides by 5. We're going to get x is equal to 2. Okay, I want you guys to go ahead and flip it on over to the back. Problems 5 through 10, I want you to work them out on your own right now.